All right, so in this question, or in this video, I mean, we're going to look at two different questions in which we're going to need to solve for the IRR. Now, on a final exam, you may not have an easy question like that, but solving for the IRR is a fundamental piece that you will need to master for larger and more complex questions on your final exam. So this video will try to kind of introduce the topic, introduce the mindset, and kind of put you in the right direction on how to solve it and what are the tools to solve it effectively. And once again, in this video, we're going to look at two different solving for IRR questions. And after this, you'll become an absolute pro. And maybe I'll even take some time to really show you why this matters and what's the range here in terms of just making sense of it. So let's begin with the first instance of a solving for IRR question. In this case, we have, and I'll put this in yellow here, we have Jake and Sarah, and they're looking into an investment. And this investment has a cost of $122,790. And the after-tax cash flows of this project will be $71,200 at the end of year one, but that amount is going to grow by 5% per year up until the end of year three. Okay? And we want to know, well, what the heck, and I'll put this in red actually, because this is our mission. This is what we're solving for. We want to know, well, what is the internal rate of return of this project? Okay. Now, I think it's worth doubling down on what the heck the IRR is. And this is a fundamental, beautiful tool that kind of gives us a lot of insights that is used a lot in the real world. I'm going to go beyond, or I guess I'm not going to go beyond the idea of, how does the IRR actually kind of applies itself in the real world and how we use it as a metric. But I will tell you why it matters in your intro finance course or your MBA class or level 1 type of CFA type of thing. The IRR, why it's really dope is because it's a very specific point. And I'll give you a little case study right here. And we could actually draw, look at this example here. We could draw a line. Okay, we're going to draw a line that's going to represent all of the different Ks that could exist, right? Once again, K is our discount rate. K is our interest rate. K is our opportunity cost, our required rate of return. It can stand for a lot of things. Okay, K is our percentage. But the reason why the IRR is so cool, and by the way, if you already noticed, go ahead and skip through the video. In an ideal world, there are timestamps, and you could find the part that works best for you. But you can notice how K represents the discount rate. And as you can see, we'll use, I guess, a random point here to display 0%. Here, we're going to have 0%. So you could have a negative discount rate or a positive discount rate, whatever works best for you. But the reason why the internal rate of return is important, and we're going to use a random point, call it here, assuming, call it the IRR was 8%. Well, the reason why the IRR is so interesting is because it's a specific point at which your NPV will be equal to 0. So I could go ahead and maybe write it here. It's a specific point, okay, where your NPV will be equal to 0, okay? So I could go ahead and write IRR right above it. So this is going to be your IRR. It's a specific point at which your NPV will be equal to 0. And the reason why this matters, all right, is that, well, any K above your IRR, okay, any discount rate that the firm has, okay, that is above the IRR, well, that is going to be a problem because this means that the company or the person or the investor has a discount rate that is higher than the internal rate of return of the project. This means that we have a reject decision because their discount rate is higher. They want a higher return than the point of indifference of this project. So any point beyond, any discount rate of a person that is beyond the internal rate of return, well, it means that this project is not working out for them, okay? Once again, K is going to be, the internal rate of return will be a very subjective point, a very objective point. The reason why I say very objective point is because it's the point for this given project with this set of cash flows and with this initial investment that will give you an NPV equal to 0. And any discount rate for the company or the person or whatever the case may be that is greater than that IRR, well, it means that this project's not working out for them because they could get better somewhere else, right? If they have a discount rate, a opportunity cost of 10%, but the IRR is only 8%, well, that means that they require more from this project than what this project could provide. But what's really awesome is that any point before the IRR. So if the company, person, or whatever has a discount rate that is smaller than the IRR, well, this means that we would have an accept decision. They would be happy with this project because the project, at its worst case, when you are indifferent, when the NPV is equal to 0, well, that point is higher than their discount rate. So for them, this is a W. This is a W, right? Let's go with an example. If, let's say, you want to invest in a project and your discount rate is 2%, well, your discount rate is 2%, and the internal rate of return of this project is 8%, so you're winning. You're winning a lot because the point of indifference for this project is way, way, way above your opportunity cost, your threshold, your minimum required rate of return. So hopefully that gave you an example, and we'll kind of work with that. Now, another point to really notice, and I've done this in a different set of videos. If you go on my YouTube channel and you look up capital budgeting, you'll see a proof on how K impacts your present value, right? The higher your K, the lower your present value. The smaller your K, the higher your present value. Work with that, okay? So that's just a quick perspective on what the IRR really means. Hopefully you looked at it, it makes sense. And if not, kind of just skip through it and we'll look at how we solve the question. So now we could solve this TAM question, in which we know that we have an initial investment. So I'll stick with green. We have an initial investment of $122,000. Okay. Now we also know that our first payment is equal to $71,200. Okay. But the thing is, this amount is growing by 5% per year. Okay. And because it's growing by 5% per year, this will kind of require us to make some adjustments. And I'm a big fan of using a timeline. When you have questions like this, it's kind of like our chapter on time value of money. It's always good to just display what the heck is going on. In this case, we can do so. So we'll have t equals 0, t equals 1, t equals 2, t equals 3. In this case, you know that on year 1, you're going to be spending $122,790. And you know that at year 1, you're going to be making $71,200. And we know that that amount will be growing by 5% every single year. Okay? By 5% every single year. So you could write 5%, 5%. The thing is, though, is that when you're looking at IRR type of questions, there are two ways to go about it. Either you could go through using the formula method, or you could go by using the calculator method. Now, on an exam, if you were to use the calculator method, you would need to make sure to add that 5% to your payments for year 2 and year 3, because or else you won't get the right value. But that can be kind of tedious, and it could actually lead you to actually making some mistakes. So it's probably better to use a formula method. Yet again, in this video, I'll show you how to use both methods just because I want to be comprehensive. So let's go ahead and let's try to use the formula method at first. If you were to use a formula method, so I guess we'll go with blue, you want to once again find a specific K. So you would do as follows. We know that the IRR is the point at which your NPV will be equal to 0. So it means that your present value, and I guess I'll zoom in a little bit just to give you a better view here. So it'll be the present value of your cash flows minus your initial investment. And we want that to be equal to 0. And we're going to solve for that specific K that will give us that point. So something like this. And because we know that our payments are growing by a specific amount for a specific amount of time, we know we're going to be dealing with a growing annuity. So we're going to do present value of growing annuity minus CF0. Now, of course, using a formula in this case would require you to have your formula sheet next to you. And lucky for you, I have it next to me right now. And we're going to have essentially payment 1 over K minus G And we would have 1 minus 1 plus g over 1 plus k. And this little thingy here, I'm going to have it to the power of n. And this will be minus 122,790 if I'm doing good quick math. Oh, wow, look at me. I remember that. That's awesome. We don't have to put a dollar figure in it. And you would solve for k. Now, this could be complex, right? Because, gosh, you got a lot of values here. You know your payment 1. We know that amount. We know our g, right? We know our n. And we have, of course, this value here. And of course, in this case, what we're solving for, we're going to highlight it in red, is we're solving for k. That's our missing variable. Now, this is not the most cute way to solve for it, but this is me showing you how to use the formula method, okay? In other words, you wouldn't want to go about using this method. It's going to be long, it's going to be hard, unless you're allowed to use, I guess, if it's an assessment or a project, you maybe want to go through that method to find a really close answer here. So you would say this is the formula method, but this is a long and tedious way of going about it. Perhaps another way that you could go about solving this question is by using the calculator method. And the calculator method would require you to use the CF plus IRR of your calculator, okay? But if you were to use the calculator method, it's really important for you to not make a mistake. And it's really important for you to find the payment for year 2 and year 3, assuming that it's growing by 5%. So what you could do is you could find payment 2 and you could find payment 3. So what you're going to do is simple. For payment 2, you're just going to do 71,200 times 1.05. And that's how you're going to find payment 2, right? And that's what we're going to plug in within our CF function later, so within our calculator. And I guess we'll copy this and we'll put it right below. And for payment 3, you're just going to do that to the power of 2. That's what you're going to plug in within your calculator, okay? So I'll show you how we go about this in a second. There you go. I'm trying to make an arrow, but it's not letting me. I'm so sorry, but I'm going to double down. There you go. Okay, so if we were to plug this in within our calculator, and I know I'm taking my time, so please don't hesitate to kind of skip through the video. I want to be courteous, but I want to give you really, like if you were with me in a private session and you have all of your questions being answered. So if we were to use a CF function, if we were to use our calculator, okay, here's how we're going to go about it. You're going to go on. You're going to go on CF, which is this function right here. You're going to press that. I would probably do second clear work just to make sure that everything is clear. So you would have the first thing that would pop off, which would be CF0. So I'll put this in a different color such that you really have all of the steps. And you would go for CF0. And what you're going to plug in, you're going to plug in 122,790. But make sure that this is a negative. Okay, and you're going to press enter. All right, then you're going to go arrow down all the way to CO1. In this case, this will be CO1 is really about your payment. Okay, CO1 will be your first payment. In this case, it'll be 71,200 if I'm not mistaken. So you're going to write that in, enter. Then you're going to put FO1, so arrow down once again. So I guess I don't have enough space, so I'm going to move this to the side. So at least you can kind of really see what's going on. Okay, you're going to go arrow down. And you're going to get FO1. In this case, FO1, you're going to leave it at 1. And what does FO1 really encapsulate? FO1, it means the frequency of this cash flow. How many times will this cash flow occur? Well, in this case, this cash flow is only going to occur once, because 71,200 won't be the cash flow for the second year. Because the second year, we're going to have 71,200 times 1.05, right? Because it grew by 5%. So you're going to go arrow down once again. And now you're going to get CO2. CO2 will be equal to 71,200 times 1.05. That will be, if you didn't have it already, 74,000 760. Okay, then you're going to go press enter. Please don't forget. You're going to go to FO2. Sorry about that. FO2. And FO2 will be equal to 1. Okay, so you do enter. FO2 is equal to 1. Now, FO3, or CO3, sorry, will be equal to 71,200 times 1.05 to the power of 2. That should give you 78,498. Now, because I want to be super comprehensive, I'm going to do it one more time just to make sure that we have the correct amount, and we do. Perfect. And then, of course, FO3 will be equal to 1. Now, I know this is not looking so cute, but I just want you to be able to review this document and kind of have everything with you. Now that we've done this, okay, now that you have all of the correct inputs, what we're going to do is we're actually going to go press on IRR, this right here. You're going to go on IRR, and you're going to have essentially nothing that's like essentially populated. What you're going to do then is simple. You're going to press compute IRR, and it should give you 36.71% or 72% if you want to round it up. So then you would do simply compute plus IRR. You can go ahead and put these in little boxes so it's cute. Alrighty, so compute IRR, and you would get that your IRR is equal to 36.72%. That's, of course, if I'm rounding it up, which is a little bit. Now, do we have the correct answer? Of course we do. So this is how you would go about solving one that has a small nuance, right? We couldn't just plug in the values one by one or use the essentially FO1 function as being like for 3 years. No, well, we had to solve for essentially the cash flow for year 1, which we already had, cash flow for year 2, which is times 1.05, and then cash flow for year 3, which is times 1.05 to the power of 2. Okay, this is a small instance of what you may need to do on an NPV question. If we look at the next question, because I said we're going to do 2. Now, once again, if this is too easy, you can get out of the video. This is just really to help the students who don't have that exposure just yet, who want to know how to solve for the IRR. We could have used our formula. In this case, the formula is very complex. Why go through all of that and further expose yourself to making an error and losing a 5% or 10% on the exam? If we look at the next one, okay, the next question is a pretty simple one in which we're going to have, once again, a solve for IRR question, okay, such that we're looking for what is the internal rate of return of the project. And we're going to have basic inputs once again, right? Your initial investment at a cost of 292,700. And then you're going to have, in this case, perpetual after-tax cash flows of 54,030 forever, okay? So let's take a step back. Now you know how to go about this, so I can go a little bit quicker, but still the general sense remains, okay? In these types of questions, there are 2 ways of going about this, either using the formula or using your calculator. But you'll see the nuance here once again. It's not as simple as that. There is a small nuance that we're going to need to account for. In this case, our CF0 is equal to 292,700. And our payment, well, our payment's interesting because it's $54,000, 50,000 like this, but it's happening forever. When you see something like this, perpetual cash flows, well, if you remember our chapter 5, right, on time value of money, if you're taking this at JMSB, well, it means that we need to use a perpetuity formula. And our perpetuity formula, once again, if you remember, is equal to PV, payment, over K. So that's interesting, okay? It's important to understand. What I'll do just for good practice is I'm still going to draw the timeline such that you have something to refer to that could give you that active recall on what the heck we're doing here. So in this case, you could draw the timeline fairly easily. You have t equals 0, t equals 1, then t equals 2. We're kind of going to leave it at that for now because we don't need anything more because we're dealing with a perpetuity. But what you notice quickly, once again, is that here we're going to have 292,700, but then we're going to have that perpetuity that's going to come into play. I don't know why I'm not able to say this word like a normal person, but it's okay. So we have 54,030, but we know that this cash flow is going to occur forever, right? So I'm going to try to draw it out nicely for y'all. There you go. So this is going to last forever because it's a perpetuity. Okay, it's going to be a perpetuity. So how we could go about this, once again, is you know that we could go about this using the formula method. We could go about this using the calculator method, but the calculator method is going to be strange because our frequency is infinity. I don't know about you, but I can't see no infinity on my calculator just yet. So there's a workaround to kind of work for this, okay? Because what a present value of the cash flow is a converging series. So it's going to meet up at one point. But anyways, that's a whole different conversation, something that you see in calculus. So there's a way to bypass getting to the answer. But because of this question, I want you to get the correct, very, very specific part. We're going to begin with the formula method, and then I'm going to show you how we could use a calculator to do this correctly, okay? It's a mix of both worlds, I guess. So we could go ahead and zoom in a little bit. And we'll move a little bit to the left. So once again, we know that what the IRR is, it's giving us a very specific point. It's giving us the point at which the present value of our cash flows less our initial investment will be equal to 0. In this case, we know that we're dealing with a perpetuity. So we would have payment over K minus our CF0, and that should give us 0. So we're going to have this essentially 5. I think I could remember the numbers. It's 54,030 over this given random point, which we don't know yet, which is K, minus, I don't remember the amount, it should be right here, 292,700. 292,700. And that should give us our K. This is a very, very, very easy computation. You're just going to do this is equal to the same thing over K, such that you would have essentially 292,700 K is equal to 54,030. And then you would have K is equal to 54,030 over 292,700. And then if I do some quick math, which I'm going to use symbol out to do, because I'm a lazy person, divided by 292,700, we should get K is equal to 0.18, something like that. 18.459. So essentially 18.459%. You could do a proof very quickly just to see if this is correct. But I'm pretty confident in my answer. We'll do that. Yeah, so you get, something very, very close to the answer. Although there are some maybe more decimal points to account for, but it's okay. So that's a pretty good approximate, okay? So that's how you would solve for the IRR for this given question. It's as easy as that. That's by using the formula method, okay? So we're going to call this the formula method, okay? Now, how do we use the calculator to help us to do this without having to do some basic quick math? Note that this was kind of easy. We were able to go through this fairly easily. However, we could use our calculator to make sense of this as well. So what we're going to do, we're going to use a classic CF plus IRR method, which is what we did at the very beginning, right? What you're going to do is you're going to go press CF, okay? Now you have data from the past. I need you to clear that. So press second, then this number here is going to clear everything. You're going to plug in your CF0 as being 292,700. Press minus, you're going to enter that. Then for CO1, once again, you're going to plug in 54,030. You're going to enter that. But what we're going to do for frequency, you're going to put the biggest amount possible, assuming do something like this, okay? Put like a big, big, big amount, all right? You're going to do enter. If it gives you an error, just go ahead and try to put a bigger amount again. In this case, try to put 1,000. It should let you do that. Okay, so you plug in 1,000. I tried to put 9 million, it didn't let me. So plug in 1,000, you should probably get close to the answer. Once you have that entered, and you know that everything's good, go to IRR, like I did, and press compute. And notice how you get 18.459. Look at that. Isn't that crazy? You get the answer. So if you want to have a way to bypass using the formula, you could just put a very big amount as being your frequency. I put 1,000. That means that you're going to get this cash flow for 1,000 years. But the idea is that these formulas that we have in finance, especially in chapter 5 for time value of money, they're all converging series, okay? Especially those that are lasting for an infinite amount of times. The further you get in amount of years, so the higher the yen, the smaller that future cash flow will be, right? A cash flow that you're going to receive in 1,000 years technically should be equal to 0, because I'm not going to be using that money. I'll be dead. You know what I'm saying? 1,000 years from now, who knows? Maybe money will not be useful anymore. So that's the reason. So these points, they converge, and that's why we're able to get the same answer. So here's how you calculate IRR, and here's how you account for the small nuances of the question. The first question, we had a growing annuity, so we had to account for that. And we were like, okay, damn, using the calculator, probably not the best way. But I mean, using the formula, sorry, is probably not the best way. So we decided to use a calculator, and we calculated for payment 2 and payment 3. Now, within the second question, we had to do a perpetuity. But we noticed that using the formula is mad easy, but we could also use our calculator and do this super quickly by plugging in a large frequency, okay? That's how you go about it. That's how you solve for the IRR. And albeit you may not see this on an exam, but this will be a crucial part of larger questions, and you want to be able to solve them effectively. So here's how you go about it. See you in the next one. You can have a bunch of resources on my website alongside YouTube, in which you can find how to do these questions step by step. And if I could do it, you could do it, because I'm a fool and I know that you're way better off. Okay, so hopefully this worked out for you. I'll see you in the next one.